When you actually start observing out into the night sky, one of the things that is hard to do is to determine locations and determine sizes. So when we want to talk about locations and sizes of things, we have a tendency to use angles in astronomy instead of linear distances. When we refer to an angular measurement, it's how many degrees would the moon, for example, actually kind of cross out. I can do better. Hold on. Here we go. So when we're measuring the distances between objects, or we're measuring the size of the object, it's how much of a circle is actually crossed or subtended by that astronomical object. The moon represents about 1/2 degree of arc. The sun, coincidentally, is also about 1/2 degree of arc that it actually crosses out. The distances across the constellation, like across the constellation Orion from top to bottom, is about 5 degrees. And we do that because it is really awkward to say, well, how tall is Orion? I can't say Orion is 2 inches tall. Orion's not 2 inches tall. And it's going to change size depending on if I'm here or if I'm at Pluto. So let's explain this angle measurement things. As you recall from what you've studied in math, there are 360 degrees in a circle. So if I start here at the 0 degree point on the x-axis, remember xy axes in math class, this is 0. You go up, you get 90 degrees. You go all the way to the other horizon, how many degrees is that going to be? Okay, that's 180 degrees. If you go down to the bottom of the circle down here, how many degrees? 270. And all the way back to the beginning of the circle, there's 360 degrees. So one complete circle is going to contain 360 individual degrees. And I certainly can't draw 360 lines. So things you should know. If something is directly above your head, it's 90 degrees up. If something is halfway between the ground level and straight above your head, well, what's halfway between straight and 90? 45. So halfway up from the horizon is going to be about 45 degrees. What astronomers have done is taken each one of these degrees and broken it into smaller pieces. And to pinpoint things in space, they take 1 degree and break it into 60 minutes. Now, the 60 minutes have nothing to do with time. Absolutely nothing to do with time. But that's just the terminology that's used, that 1 degree of arc is broken into 60 minutes of arc. If you take 1 minute of arc, it can be broken into 60 seconds of arc. Now, how this is noted is a minute of arc is noted by a little, like that, a little caret up top, so 60 minutes. 60 seconds of arc is 2 little carets. If I had 45 minutes, it would look like that. If I had 30 seconds of arc, it would look like that. And if I had 10 degrees of arc, it would look like that. The challenge or the situation with angle measurement, it's all based on perspective. It's all based on you and I standing there looking at something. And so the size an object is going to depend upon its actual size and how far away it is. We've all seen this situation where you might have a mailbox that's very close to you, and you might have a tree that's a long way away from you, and the mailbox looks bigger than the tree. And you know the mailbox is shorter than the tree, but because the mailbox is closer, it actually looks larger. Same thing happens when we look out into space. So as we measure these angle measurements, they're just having to do with what we see, what we observe. The sun's diameter happens to be about 400 times bigger than the moon, but the moon is about 400 times further away. And this is a weird coincidence. I can't spell coincidence. It's a weird coincidence that the sun and the moon appear to be the same size in the sky. And it's because of this that we get solar eclipses, total solar eclipses. I want you to understand how to measure angles with your body. When you're out with your sweetie pie and you're looking at the stars, you're not that nerdy. You're not going to haul out a protractor and measure something with a protractor. But if you want to measure how far across a particular star is or how high a particular constellation is, it's really easy to do with your body. So if you stand with your hand at arm's length, so hold your hand out at arm's length, and you hold your pinky out, your pinky is going to cover about 1 degree of arc. If you go into like a Cub Scout, Girl Scout salute, 3-finger salute, that's going to cover about 5 degrees of arc. Your fist, closed fist, is about 10. If you do like hook 'em horns, I think it's that, some Texas football team, yeah, that's got that. That is 15 degrees of arc. And if you go to Hawaii and you're going to do the hang loose symbol in Hawaii, between your pinky and your thumb, that's about 25 degrees of arc. So I am not standing in front of you, but what I'm going to ask you to do is pause the video, and I want you to practice, and I want you to measure 2 or 3 things. Maybe a building that's outside, maybe the height of your closet. And one of the questions I want you to come back and answer is this: as you get further away, or the object gets further away, what happens to the angle? Does it get bigger or does it get smaller? So hit pause, go measure a couple things, and come back. Okay, are you back? All right, as you got further and further away from whatever you're looking at, what I'm suspecting should happen is the further away objects are going to occupy a smaller angle than the things that are really, really close. And so they're going to have a smaller angle because of their increased distance. It doesn't mean they're actually smaller. It just means that's the way it works. All right, guys, that concludes the stuff for this lecture, and we will see you later.